Alright, so here we have a parabola that opens downward, and again, I will try my best to explain to you the different parts of this parabola, locate them, and how they relate to each other. Of course, I have another video about parabola explaining to you the same exact thing, but that parabola opens upward. So if you want to watch that video, you can do that and look for it in my YouTube channel and try to compare that to this video. So let's begin by naming the equation that represents this graph. It's x minus 1 squared equals negative 12 times y plus 5. So two things you need to remember. Number one, if the one with a square is the variable x, that means it opens either upward or downward. This one opens downward because you look at the right side of this is negative. Okay. Also, maybe you already know this. Maybe your teacher already told you this. If p is a negative number, the parabola opens downward. Though here we still don't have the p, but we will be able to find that using the general equation for this type of parabola, and that's x minus h squared equals 4p times y minus k. Now in solving for p, we have 4p equals negative 12. Negative 12 divided by 4, so p equals negative 3. And we will be using that value of p in order for us to find the other parts of this parabola. Again, I will repeat this. If p is less than 0, just like I think you already know this, the parabola opens downward. Okay, let's locate the vertex of this parabola. We can see that from the equation, and that's from the vertex is at 1 and negative 5. And of course, we have this imaginary line that divides the parabola into two equal parts. We call that the axis of symmetry. And whatever the value of your h, that's going to be your value of axis of symmetry. Okay? That's true if the parabola opens upward or downward. So here our h is 1. That means x equals 1, which is the axis of symmetry. Now let's locate the focus of this. So the distance of the focus and the vertex is equal to the absolute value of p. Our p here is negative 3. Absolute value of that's correct, it's 3. So you move 3 units down from the vertex and you will have this point. Okay, and of course there's a formula for that just in case you don't have the graphical representation of the graph. And the formula rather is h and k plus p. So h, whatever the h of your vertex, is going to be the h of your focus, the x coordinate, and that's 1. When it comes to the p, or the y coordinate rather, the formula is k plus p. So k is negative 5 plus negative 3, that's negative 8. Right? So now we have this coordinates. And of course, on the other side of that, we have the directrix. That's this one. And again, the distance of that from the vertex is the same as the distance of the vertex to the focus. Now, if we don't have the graphical representation, we can use this formula, k minus p. K is negative 5 minus negative 3. I think I need to write that down. Okay. So I'll write it down. So k is negative 5, minus negative 3. And that's going to give us negative 2. And then, of course, again, I want to emphasize this distance of the vertex to the directrix is equal to the absolute value of p. That's the same as the distance of the vertex to the focus. And of course, second to the last thing that we will find here are the ends of the LR. So let's start with the ones on the left. Here, that purple dot. Okay, that coordinate, or the coordinate of that, specifically the y coordinate of that, is the same as the y coordinate of the focus. Okay, so if we want to know the formula, it will be h minus the absolute value of 2p, and then k plus p, again, same as the y coordinate of our focus. So here, h is 1 minus 2 times negative 3. Absolute value of that. So that would be 6. 1 minus 6 is equal to negative 5. So negative 5 and negative 8. And the right end of this LR, or latus rectum, we have this point. The formula for the x coordinate is going to be h plus 2p this time. K plus p for the y coordinate is the same as the focus and the left end of this LR. So h is positive 1, right? Plus 6. 2 times 3, negative 3, is equal to negative 6. But we want to know the absolute value of that. And that will be equal to 7 and negative 8. And of course, we have this LR, and the length of that is equal to the absolute value of 4p. And we can clearly see that from our equation. So we have negative 12, absolute value of that is equal to 12.